There appears to be some confusion in the Irish market about the requirement for a 13 Newton thermal block, and we're getting asked more and more by our customers, do you manufacture a 13 Newton Quinn Lite block, or do I need to use a 13 Newton Quinn Lite block? So we're going to try and cover that off in this video. There'll be two reasons why you would use a 13 Newton block in a masonry structure. Firstly, structural. If you have a building which is subject to high loading, for example a high-rise building or a commercial building, your structural engineer may specify a 13 Newton block for structural reasons. And if that's the case, then you need to use a 13 Newton block. The other reason why 13 Newton blocks may be specified is for durability. The higher cement content of a 13 Newton block makes it more durable. So if you need to use a block with higher durability in certain locations, then a 13 Newton dense block is fine. However, if we're looking at thermal blocks, we need to give more consideration whether a 13 Newton lightweight block is adequate in certain situations. So we're going to look at that now. Table 14 of NSAI publication SR 325 covers durability of masonry and finished construction. Now the table has various sections, and today we're going to look at section A, work below or near finished ground level. Table 14 shows various exposure conditions, starting with MX 2.1, which is low saturation without freezing, going on to low saturation with freezing, high saturation without freezing, and finally worst case MX 3.2, high saturation with freezing. Now the table defines MX 3.2 as being located in an area 150 millimeters above and 150 millimeters below finished external ground level. So we're looking at this zone here. So the table sets out the requirements for aggregate blocks to meet MX 3.2, and the three requirements are: the block needs to be 13 Newton in strength, and this is why we're seeing 13 Newton blocks and more specifications. But the other requirements are: the block needs to be greater than 1500 kgs per cubic meter in density, and it needs to be manufactured with dense aggregate blocks. And currently there's no thermal block available on the market in Ireland which meets all three requirements. Now there is a solution to MX 3.2 if you need a thermal block that meets this condition. Our Quinn Lite block is suitable and certified for use. So we look now at why that is. When it comes to the use of aircrete blocks such as Quinn Lite, the direction of SR 325 table 14 is to refer to the manufacturer for suitability of use. The key difference between aggregate blocks, which are defined in table 14, and Quinn Lite blocks is that there's currently no test method, freeze-thaw test method available for aggregate concrete blocks. However, there is a recognised test method for AAC or Quinn Lite blocks. Now, all our Quinn Lite blocks have been tested for freeze-thaw and are third-party certified for all ground conditions up to and including MX 3.2. It's also covered in standard EN 1996 Part 2 specification of masonry for durability, Table B1 clearly states that AAC blocks meet the requirements of MX 3.2. Okay, so we've covered off the fact that the Quinn Lite thermal block is the only thermal block available on the market in Ireland that actually meets the requirements of MX 3.2. But if we look at the location of MX 3.2, which is this area here, there's actually no requirement for a thermal block. A thermal block in this location is not improving the thermal performance of your junction. If we look at where thermal blocks are generally specified, Quinn Lite blocks specified for thermal bridging in this location generally only need to be limited to this location to get very good thermal performance. If, however, you're looking at some of the poor performing thermal blocks on the market in Ireland, you may on occasion see them specified at this location, and that may be a requirement to get a similar performance to that of the Quinn Lite block, which is used here. So if we look then at what Table 14 requires for blocks used sort of in this location here, it's not MX 3.2 because it's lower than 150 millimeter below external ground level. So Table 14 states that for this location you don't need a 13 Newton block, that a 7.5 Newton block is adequate. However, it still states that the block has to have a density of greater than 1500 kgs per cubic meter, and it has to be manufactured with dense aggregates. So, like before, there's no thermal block available on the market in Ireland that meets those requirements. So if for some reason the designer wants to specify a thermal block in this location in addition to this location, perhaps using trench blocks from the foundation up, then the Quinn Lite block is again the only thermal block available on the market in Ireland which can be used in all those locations. So I hope that goes in some way to clear up some of the confusion about the use of 13 Newton thermal blocks in masonry construction. But just in summary, for any of the conditions set out in Table 14A, from low saturation without freezing right up into high saturation with freezing, the Quinn Lite thermal block is the only thermal block available, suitable and certified for use in these conditions.